There it is. Okay, the other thing to remember is that traditionally you use mercury in a Warburg. Unfortunately, that's got its own problems. So we use water. Got to remember that a hard vacuum with water is 32 feet of pull. So this apparatus is super sensitive to any volume changes. A couple of degrees in temperature change will start affecting the column height by inches. So put everything in the barrel cellar, make sure the temperatures are all the same before you start trying to stick things together. Because a warm flask or warm wine, you're not starting from zero.
I see. So you let the wine come to cellar temperature before you turn it on.
And the apparatus.
Yeah.
This is our high-tech support structure right here. We spent a fortune on this, having it custom made. And so you notice the carefully engineered shelving system here for the bottles.
Oh yeah, it's pretty high tech, all right.
We had these amber bottles custom made for us by Granger's. And the little barb fitting is an 1/8 inch bulkhead fitting, also custom made from us by Granger's too. 6 foot of 1/8 inch ID by 3/16 OD vinyl tubing, also custom made for us by Ace Hardware. Cut to length by a friendly salesperson.
So, in other words, the whole setup here kind of looks to me like around $100.
That included the candy bars and the gas to go get this stuff.
Okay.
All right, this bottle is actually a 275 ml bottle, so we're using 156 ml of wine.
And the advantage of the screw cap, as you said, is that it doesn't give you a volume change when you put it in.
There's no volume change, you shove it in. And the other advantage is these corks tend to pop out when they're wet.
Yeah.
Which makes it discouraging to find your careful experiment you've been running over the weekend is still reading 0 on 1. So our super accurate measurement system.
We usually weigh those volumes.
You take the weight?
Yeah, we take the weight. If you want to be accurate.
Want to be accurate. $2 ml. I know you lab types are probably going to be going with a sloppy operation. This is too bad.
We can cut that out.
156 ml of wine. Make a little room right up here. Once you put the lye in, you don't want to waste a lot of time with this because the reaction's right away.
Mm-hmm. So what we're doing is moving all of the phenolics into the phenolate form, so instead of having one molecule in 100,000 that can react, they can all react because the pKa is around 9.
All right. Fortunately, you do have a little time because it takes a little bit of time for the crystals to actually start dissolving. My high-techy lab scoop.
That's a big pen you had made for you there?
Yes, it is. Custom-made clear barrel. Stick the end in your magic marking solution, which is just water and a little red food coloring.
You just
courtesy of Rayleigh's. It's in, it's underneath the cover, and then give the bottle some swirling action here to make sure the lye dissolves. And you'll find that it does warm up slightly when it does that. So just be patient. It'll cool off and start pulling a vacuum.
It'll take about an hour before it pulls anything.
Yeah.
And
but you're good.
The measurements, we were talking about the measurements. Well, We just measure the height of the column, but you want to make sure you don't take this into account. So we subtract about 3 inches here.
Usually set that as some easy to remember height of fluid in there, then we go ahead and measure this. Currently we're at 21 inches, 24 minus 3.
So you've got some other things running here. What's that?
We have a gallic acid equivalent standard.
Okay.
Which we tend to try to run just so we have some idea of whether we're doing anything the same or not.
And it's what's the concentration?
500 milligrams per liter.
Okay.
Yeah. So we're looking to see that it pulls at least the same reasonable height every time. And then we're running some of micro-ox and non-micro-ox line. And what we just put in was a half and half.
And what's the result you're getting with and without the oxygenation?
Enough, apparently.
The micro-ox seems to be pulling a little more vacuum than the regular lot. There's about, what is it, a 3 or 4 inch difference. And that's about a 30 gallic acid equivalent difference, maybe.
Yeah, so it looks like about maybe 10 or 15% difference.
Something like that, 10 or 15% difference.
So, you know, I mean, that's not odd. I told you that was going to happen. But it is counterintuitive.
It's counterintuitive, so we were a little bit,
Yeah, it's a kind of homeopathic where you challenge the system with oxygen and it takes up more oxygen.
Exactly, so it made even more. So. But so this is the perfect setup for these kinds of experiments. And we are running another one where we added at a smaller dose some oxygen in it. We suspect that it will pull even more oxygen than the standard. So
that's what you're running there.
That's what we're running there.
And so, how long do you run it?
And these run for about 24 hours, right? But they can, after 24-hour period, they seem to they seem to die off a little bit.
But they never really stop.
They're not really, well, they do, and they might take a week before they stop. The wine seems to take a bit longer. The gallic acid equivalent, the standard, seems to stop a little bit more, frankly.
Do you think that this could be done in like in an 8-hour shift and just cut it off at a standard time?
Yeah, but 8 hours would be too soon. Maybe 24, maybe 48 hours.
I think you might be able to see something. You might be able to see, you won't get the final result, but you might be able to see already the shift that's happening.
Yes.
Right, that's what I'm saying. It wouldn't be the final result, but the question is, can we get something that's a standard method that can be done in a work day?
I don't know about 1 day. 8 hours might not be enough.
You start to see some trends at the beginning. I would say
it might be possible. Definitely.
You'll see a trend, I mean, if everybody does it at 8 hours, then it might be possible to compare things.
Okay, and then John, why don't you talk about that pressure transducer idea that you had?
Oh, there is available, if anybody wants to spend the $550 for it, a pressure transducer that's quite sensitive in this range of very mild vacuums that comes directly with a USB plug on a 6-foot cord out of the end of it, and it comes with the CD, a software for it, so that you can plug it directly in your laptop and have it do all the recording and graphing for you, so you don't have to write these things down and measure them with the tape measure.
And you also wouldn't have any volume correction.
And there would be no volume correction.
For the air in the hose.
Right, which we're not currently compensating for. We're just doing this as relative measurements.
But we figured out that was about 16 cc's in the hose.
16 cc's in the hose, you could probably come up with a graph or a chart that would allow you to compensate, depending on what your final reading is, for the decrease in volume in there. We haven't worked that hard yet.
Yeah. Okay. Anything else?
Nope.
Great. I really want to congratulate you guys on taking this and running with it.
It's fun.
Mathematics is pretty simple.
Yeah.